All right. Well, welcome. How has your first week been? Good. All right. Good. We have some bad news this week, which is that you have homework. Homework 1 has already been released, and it's due next week. It's on Relay. It's pretty simple. And we'll cover everything that you need to know for the homework in class today. So if you're confused about stuff, pay attention. We'll make sure that you know what's up with that. But yeah, it is due next Tuesday at midnight. We will have office hours also to help with this. We'll give you exact rooms on Piazza after, but it'll happen from 5 to 8 on Thursday, Friday, and Monday. So that's 9 hours of help for the 9 questions that are on the homework. So if you're really struggling, we'll make sure that you guys know what's happening. All right, who doesn't know what a hackerspace is? A few of you. All right, cool. Who hasn't filled out the hackerspace form? One more of you. Okay. Next one. So hackerspaces, there's 3 of those. Data science, web dev, and mobile. If you haven't filled out the form, I will send me a message on Slack. I'll send you the link to the form, and then pretty much you guys, the rest of you that know what's happening, we'll send you a link to we'll send you an email with your hackerspace assignments tonight, and they will have all this room information, but the ones in bold are important because they start tomorrow. So if you're assigned the web dev or mobile dev hackerspace, those are the room numbers, and we'll send that in email as well. But they'll be 7 to 8 p.m. tomorrow, never that. If you have a time conflict with the one that you're assigned, or you really just don't want to do, really don't want to do the one that you're assigned, send me an email and we'll see what we can do. No guarantees. Cool, so today we'll be doing 3 different things. The first will be your intro to Python, which will be done by Allegra. And then we have a lecture on interviews and how you can build a good resume and get an internship as a freshman. And then we'll have another lecture on the basics of Git, Bash, and all that. So, cool.
Okay, so welcome to our very first week of Python. So just out of curiosity, does anybody still remember who I am? Does anybody actually remember my name? Okay, so I'm Allegra. So basically today we're going to cover some fundamentals of Python. So if you've programmed before, you might be really familiar with these concepts, and this might just be super easy for you. If you've never coded before, that's totally fine. This might just be a little bit of a review from 125 stuff and maybe something new. Okay, so raise your hand if you've coded in Python before. Okay, so we've got quite a few. All right, so we want to talk about some things, some properties of Python. So Python is a high-level language, and we have a definition here, which basically says that high-level means you're far away from the machine code. So we're not talking about, doing stuff that's very closely related to the hardware. We're talking about abstracting all of that away. So can anybody give me an example of another high-level language? Yeah, you. Java? Yeah, great. That's a good one. Yeah.
C#?
C sharp, yeah, okay, so that's pretty good. And so we have those. We also have the opposite of those, low-level languages. So has anybody coded in a low-level language before? All right, so what languages? Yeah, C is a good example. So when you go on to take 241, you'll do your labs and your MPs in C. So you'll get super familiar with that. Yeah, so things like C, C++. Has anybody heard about Rust? Yeah, okay, so Rust is really popular right now. I'm learning it right now personally. It's really fun, so you guys should check that out if you're interested in low-level languages. But today we're talking about a very high-level language. So something that people like about Python a lot is that it has very simple syntax, don't deal with memory, and it's very fast, right? So it's got a combination of these traits. It's imperative, so basically each instruction tells the program what it's supposed to do. So that's the opposite of like a functional language. So when you look at things like Lisp, if you've heard of that, it's a different kind of logic. So you guys will get to that eventually, but yeah, this is imperative. The other thing is it's interpreted. So if you've done stuff with C or C++, you have to compile first to get your executable, and then you run that. But with this, it's actually executed as it goes. Okay, so something about Python. So they came up with this doc that's called the Zen of Python, and that's basically all these principles about what Python is supposed to be like. So it's supposed to be beautiful, it's supposed to be simple, it's very streamlined. You don't have a lot of extra things floating around. So you guys a lot of you are in 125, and you know that you always have to remember your semicolons, and there's all this syntax, and it gets complicated. Some people really like that, but some people prefer for it to be simple. And when you're doing the types of things that you might do with Python, it can be helpful. So can anybody tell me like a use, why would you use Python versus like another language? Yeah. Yeah. So, yeah, exactly. There's a ton of libraries for like machine learning and data science, data analysis, and visualization. When you go on to take numerical methods, you'll use Python to draw a bunch of like plots and stuff like that, and actually analyze data. So yeah, it's very fast, which is useful. All right, and then you can also, a lot of people use it for like web and like other kinds of applications. Okay, so we have a little blurb here about installing Python. So can everybody read this? Is it visible in the back row?
Yeah.
Okay, great. Okay, so you don't have to do this right now. You're going to want to do this eventually, though. So the first homework, if anybody's actually looked at it, you would know it's on Relate. So it's just multiple choice, and then you have a coding question at the end, but that is going to run itself in Relate. So you don't need to set this up yet, but I highly recommend that you do. After the third week, after the fourth week. In the future, your homeworks will be using Git. So you'll have to actually run these files on your own computer and then commit them. So you want to get this set up now so that if you have any problems, you can come to office hours or come to us after lecture and actually get help getting this installed. Okay, and I'll post this after lecture so you guys can reference this if you need to see how to do this. Okay, yeah, and then you can see here basically, if you go ahead and do this on your computer, you just make the file, you're gonna write your code and then save it, and the command is super simple, it's just Python and the file name. So yeah, and then if you like IDEs, you can use those too. Okay, so today, if you wanna follow along with what I'm doing, you can use this. So this is a playground for Python, so you can type things here and run them. You also have like a little terminal here. But yeah, I recommend that you follow along. I think it's a lot easier to learn. It just reinforces what you're learning if you actually do it at the same time. And you can sort of play around with things. Okay, so we have a couple of different things to go over. So first thing, in any language, classic thing to do is print out hello world. So let's take a look at how you actually do that in Python. So here we've got print, parentheses, and then just the string in quotes. So it's very, very simple. There's no semicolon. We don't have to do put a bunch of other parameters in here. And then if I run this, yeah, it prints out hello world, right? So it's really simple. And it's different from other languages, right? So it's much bigger pain if you have to use like Java, or it's a huge pain in C sometimes. Like there's a ton of other stuff you need to put in there to get it to work. So it's pretty simple. Okay, so we figured that out, but that doesn't really give us too much. So in order to actually do more complex things, we want to be able to do more than print, right? So we've got all these different variable types, and it's important to understand what these actually are and how to use them. So we have ints, floats, booleans, and strings, and then also lists, which we'll cover in a later lecture, but also very important. All right, so someone just shout out, what type is this going to be? Yeah, right? That's really easy. What about this? Mm-hmm. Okay, I'd be like really surprised if you got this one wrong, honestly. Okay. What about this one? All right, yeah. Okay, so that's pretty easy, right? You guys have probably seen this in whatever CS class you've taken before, or here in 125. Other important operators, so we've got several other things. So I remember when I took this class, it took me forever for some reason to realize that to get an exponent, all you have to do is this. I had never taken a CS class before, so I tried to write like this function to implement this, and I didn't realize it was a thing. So yeah, this raises it to a power, so we've got 5 squared. That's really easy. And then we have modulus. So what does modulus do? Back there? I don't know if you have your hand up. Sort of looks like you do. No, okay. Yeah. Yeah, exactly. So we're going to get the remainder. So with this, you can see 5 mod 3 is going to be 1, right? Because 3 goes into 5. Oh, sorry, not 1, 2. Let's say that. Okay. Well, yeah, because 5 divided by 3 is going to be 1, but the remainder is 2. So, yeah. So basically, when you divide the number, it's just going to like truncate into like round it down to like the nearest int, and then the remainder, you can see there would be 2 left over. So what if we do this though? What are we going to get?
0.
All right, what if we do this? Oh, yeah, that's fine. What if we do this?
5.
Yep, we get 5, right? Okay. So it's important to understand how that works so you don't get any surprises when you go to code stuff. Okay, are there any questions so far? Okay, don't be afraid to ask questions even if you're confused. Yeah?
I forget, so I'm just going to ask you, what's Python's behavior for negative modulo positive?
Negative modulo positive?
So like negative 5 mod 57, is that negative 5 or 52?
52?
Okay.
All right, so yeah, good to know. That's a good question though, because yeah, it's sort of like you're not sure what the behavior is, then sometimes just run it and see what happens. But yeah, okay. So yeah, now that we've actually covered what the various variables are and the operations, so these are in addition to like the ones that you should know. So adding, subtracting, multiplying, dividing. We've got these. Now let's see like what we can actually do with this. Okay, so declaring variables in Python is super easy. So Python doesn't require you to actually explicitly declare the type of the variable. So you can see here, we just have x, right? So we don't have any type or anything like that, right? You can declare a type if you want, but you don't have to. So we have this. If we run this, and then do this, we can see we get 15, right? So if we do this, oh shoot, it doesn't like that. Okay. Oh yeah, you're right. Okay. No.
It's int of x.
Okay. Okay. We'll look up the syntax for that later. But yeah. all you need to know is you don't have to declare a type, so you don't even have to mess with that. If you want to, you can definitely look into it. There is a way to do it, I just never do it because you don't have to. But yeah, okay. So then we can declare other variables. We have A here, B, C, and then we have some strings here, like this. So what am I gonna get when I run A plus B? So you say it's going to concatenate them? Okay, anybody else? Okay, so it's basically just gonna add them, right? So when we do that, we get 3.4. And so you can see we added an int and a float, right? But it gave us a float back. So here when we did type, if we do type here, you can see, yeah, there is also float. So it's important to understand how the operations that you're doing affect what types you're getting back. This is super important because as you get farther in your programming career, you start doing more complex things. It can be a real problem if you're not getting the right type back because you might be losing accuracy. Okay, and then what do you think we're going to get back when we print D plus E? Mm-hmm, yeah. So, yeah.
Hello world expanded.
It'll be available after lecture. Mm-hmm, okay. Yeah, so you get this, right? So in this case, it concatenated them. So it put the two strings together. So with the plus operator, it depends on the type, right? So when it sees two numbers, it adds them. But in different situations, it's gonna change its behavior. So in this case, it's concatenating them. For what? So if we do this, something like this, yeah, it still works. So it doesn't actually, make a difference. Mm-hmm. Okay, any other questions before we move on? Okay, so now we have functions. Does anybody, what's a function? Someone raise your hand. Yeah, you back there.
It gets an input and it returns an output.
Yeah, exactly. Okay. So that's pretty simple, right? But basically, yeah, it takes in parameters and then it returns. You do something and you can return a value. Yeah. So we go over the difference between returning and printing. This can be tricky if you're new. What's the difference? And this is a question we get a lot. Yeah. Oh, okay. Okay, so that's sort of on the right track. So basically printing, so let's say we write a function, right? And it prints something. So it's printing it to what's called standard output. But when we return something in a function, all it's doing is taking that value and sending it back to where we called it. So if I have my main function, right? And that's where I'm writing all my code, and I call a function called, let's say, like add. And I add two numbers in that function and return that value, and that's going to come back and return to the original function. Okay, so printing is basically just sending something to the output. It's not actually returning the values, and you won't have that value to actually do anything with when you come back to the function. Okay. Yeah, and so another benefit of having a function is we could write, so we have our main function, right? We could write code in that function to do something, right? But let's say we write a loop or something like that, right? Like let's say we want to do the same thing 100 times. Are we going to write the same code 100 times? You're not going to want to do that, right? So even in the case where, let's say your function is 100 lines long or something like that, you don't want to have that just floating around. So putting it in a function takes it away, packages it up, and it makes it easy to reuse. And it's very clear what it's doing. Yeah. So we give an input, we give an output, and then here's the syntax for that. So in Python, we use this def keyword, and then the name, the parameters go here, and then once again, remember we don't need types, so that makes things pretty easy. And then you can do anything, right? So here we're just printing. So when we actually run this function, we get that, right? Now what happens if I do this, and let's see. So let's say I declare a variable, and I do this, and I want to pass this in. What do you think is going to happen? Yeah, we get an error, right? Because that's not what we defined it to do. So you always need to make sure that how you define the function is how you actually use it, right? So we can't just go throwing around ints, using them as parameters in a function that doesn't take parameters, right? Okay, so yeah, so that's a pretty simple function, just prints hello world. And then getting to parameters. So basically, here we actually have a parameter. It takes in a string, presumably called phrase, and then it prints that, right? So when we run this, we get that, right? Now what happens if I do this? What? I heard someone say something. Yeah. Okay, yeah, so it's not going to actually print anything anymore, right? Yeah, so we see the output here is the value, but it's not actually, it's not printing that. Yeah, so that's a good point. And basically, yeah, just knowing the distinction between, printing something and having something show up and actually returning something is pretty important, right? Okay, yeah, so this covers what we just talked about. Basically, you can return a value and then you can go ahead and use that for other things. That's basically the most important thing, right? So here in Python, pretty simple. We're not messing around with memory, so anything that you do in the function, you can go ahead and return that value. In other languages, it gets more complicated because you might be messing around with memory addresses and things like that. But this is nice and simple. Yeah, and then other functions, so they're not all going to be functions that you write. So I think someone said before, there's a lot of really good libraries for Python. So those are other functions you might use, somebody else's. Yeah, and this covers this basically, that a program is this set of instructions, and that when something returns, it basically returns the point in the code where it came from. So when you want to take the computer architecture or something, you'll see that you will save the memory address, you'll save that parameter because you'll go to another function in a different place in memory and then come back, and you need to remember where you were. Okay, so yeah, so there's different things, standard output and standard input. So input's the opposite, it's if we want to actually get, you have a question? Yes. So you don't need to. So you can set up the type if you want to, but that's not something that I do. But we can cover that next lecture. I'll look it up. But essentially, it's basically just not something that people usually do just because it's easier not to. And then you can just make sure that it's getting used the right way. And I think you can put in some sort of safeguards against using it with other types. Okay, so let's see here. Okay, yeah, so you don't have to just have one parameter. Here you can see our function takes in two, and it adds them and returns them, right? So in this function, we're doing both printing and returning. So it's not just, if we want to print something, we want to get that value back. So it's not just leaving it there. It's actually returning it to us too. So here we have that. And if I wanted to say y equals this, and then we say print y, then we can see it printed out. So yeah, so it's very useful to actually get those values back and put them inside variables, store them there. Okay, so also we you have another function here, does subtraction, really similar thing. And here's an example of actually printing out this function. Let's see. Okay, so these are just some examples. So if we do this, what are we going to get from this function? This is an example from this part. You just shout it out.
4.
Yeah, so you have 1 and 3, right? You're just adding them. I swear I heard a bunch of people say 1 for some reason, but okay. Yeah, and so you can see here, we're just getting, yeah. Okay, and then if we do an example with this, where we have sub, let's try printing out that. So you can also include function calls in print. All right, so let's say sub, I'll do, whoops. You want to be careful that you have like matching parentheses and everything, because it can get a little bit confusing when you have a ton of them. But let's just do 2 numbers. Yeah, we get -2, right? Okay. So yeah, basically you can put sort of anything in print. So anything like a function call, variables, you can put strings and variables if you wanted to say, let's see. That should work. Oh, that is not the way to do it. Oh yeah, you're right. There we go. Okay, good catch. Yeah. So basically, you can combine anything you want. It's a really useful way to actually see what's going on. So when you're starting out and you know, you don't have a lot of really like, I don't know, advanced debugging techniques, printing is always a good way to see what's going on. So before you come to office hours and you're like, I don't know what's going on, we don't really want to sit and help you debug your code. We want to help you learn how to do that. So definitely going through, printing out the values of variables, setting breakpoints in your code, so spots where before and after a value changes, so you can make sure it's changing to the right thing. All of those things you can do on your own before you come in and actually get help. So yeah, so in this course, really emphasize being independent. Of course, it's great to ask for help, but make sure you actually try to fix the problem on your own before you do that. Okay, does anybody have any questions? Okay, so next week we're gonna start diving into some more advanced stuff. Today was pretty basic, but we need to get everybody up to speed with like syntax and stuff like that. So yeah, first homework will be out. It's gonna be due next Tuesday at midnight, so make sure that you're prepared for that. And then yeah, go ahead, come to office hours, ask questions on Piazza. Yeah. Okay, so now we're gonna have a couple micro lectures. So yeah, so first we have interviewing. So
Hi guys, my name is Rohan, and I know you guys are all freshmen. You guys are all excited to be here, and a big part of being in CS, and a big part of like going into a software engineering career is getting an internship and interviewing for full-time positions and going through that whole process. And it's like a thing that you won't necessarily learn in a class, which is why we have 196 here, so that you guys can gain more experience with that. So let's talk about interviews. So you guys just got here, and I don't want to hit you. I know that you guys are getting used to college and stuff like that, but interviews happen now. So like the fall season is when people are most actively recruiting for internships for next summer. And even though it seems early, it's like you know, similar to college apps. It happens a long time before it, but it's our career fairs are happening next week and stuff, and the week after. So now's the time that you want to get out there and like start talking to companies and getting your name on their in their books. So this is just a graph of like interview density over time, but as you can see, it's really high in the fall and it peaks in like November. So you want to try and do as much as you can first semester and see where you can go with it. Question?
I was just wondering where you collected this data from.
To be honest, I have no idea. I took these slides from, or I took some of these slides from someone who made them last year. So So the first step to like kind of going through the process is, so you're gonna have to get the interviews and you're gonna have to pass them. And the harder part, honestly, as a freshman is getting the interviews because it's your first year in college, you don't have a ton of experience yet, so it's hard to show to a recruiter or someone in the company that you're credible enough to intern there or do some work for them. So there are 3 ways to get interviews: referrals, career fairs, and online applications, right? So referrals are by far the best way to get an interview. So if you know someone who worked at a company, you know someone who's full-time at Microsoft or something, you can ask them for an interview or ask them for a referral and you'll get into the system because someone from that company can vouch for you. And then after that, career fairs. This can seem tedious, especially when you guys are going to go to your first career fairs next week. You'll see that there are a lot of companies with super long lines and you're just kind of taking your bets with whichever ones you want to talk to. But they're still a lot more effective than applying online because the company's actually here and recruiters are actually here to talk to you more about that. And that's something you'll talk about more in like Engineering 100 and stuff too. So that's the place where you can learn more about how career fairs and stuff. I'm going to talk to you guys a lot more about the interview side of things today because there's a lot of like technicalities with that we can get into. And then online submissions, which is pretty basic. You go on their website, you attach your resume, put your information, and go on there. And a question I get with this one a lot is that, do I need to write a cover letter? Like I see an option for a cover letter. I've never written a cover letter and still been able to get interviews places, so I don't think it's that necessary, and I think most people would agree that it's not really something that helps you that much. And inevitably, as you guys are freshmen, I think last year I probably got rejected from like 70 plus internships, so it's not a big deal. And you could get rejected straight away just from your resume, and that's not because your resume was bad, it might just be because they saw your graduation date on your resume and just called it off right there, or it might just be because they don't think you have enough experience yet. But essentially you can get resume rejected or get rejected after your performance on an interview. So these are just some tips about like how to format your resume better, but I would highly recommend for this, there's an interview workshop happening later this week, and it's the first in a series of ACM's interview workshops, and the first one's going to touch heavily on how you want to build up your resume so that like tech companies can look at yours more. So, but these are pretty important tips to have, especially with keeping your GitHub on there and putting a lot of projects on there, because I know most of you won't come in having an internship before, or having some sort of work experience in like software engineering or CS, but having projects on there shows that you're able to write code that is an actual application or can actually do something outside of code in a classroom. Because the first thing that you'll notice when you do get your first internship, as all of you will, like writing code for your job and being a software engineer is strikingly different from writing code in 125, 126, or any class that you work on here. Because the development cycle and the way you build things is just like a completely different way of approaching it. And another thing is that a lot of the times you'll get asked when you're talking to a recruiter or when you're somewhere, just in general, is like what you're interested in, what you want to specialize in. And that may feel like, you may feel under pressure that like, hey, like I want to specialize in this, and like I know like half of you came in thinking you want to do machine learning, and like so the best thing to do is just to say that you're interested in whatever, but if you specifically want to work on something for that company, then it's fine to tell them about that. So now we're going to talk about the interview process, and it can usually be really long, and it can be like intimidating, and depending on what companies you're interviewing with, they have different processes, but these are kind of like 5 different components of like what can make up a hiring process, and companies may only have one of these. They may have all 5. They may have like 3 of them. So some companies may have a recruiter call you in a coding challenge and an on-site, but then no phone technical, etc., etc. So essentially, each of those, a recruiter phone screen is usually like a short conversation that you have with a recruiter from the company. So this person's not technical. They're not looking to ask you questions about like what languages you know or anything like that. They're just looking to get an idea of what you're looking for in an internship and like what you want to do with them. And then a coding challenge, we're going to get to it actually, but first we'll talk about the behavioral part. So right now you guys are, again, so a lot of the companies you'll be interviewing with won't necessarily be big hotshot tech companies in the Bay or in Seattle, you know, because those companies are hard for you to get like hands-on as a freshman, so it's going to be a lot more companies in Research Park and companies that have software engineering and software development positions available for students, but aren't necessarily hotshot tech companies that everyone wants to apply to. So those companies are, especially the ones in Research Park, are a lot more conducive to working with freshmen. And the thing that's really great about those is a lot of them don't necessarily have like a technical interview process. They don't necessarily have you write code in your process to interview with them. So it's really important to just kind of be able to talk about yourself, because there will be an interview process and it'll be like behavioral questions about you. And I know a lot of you guys have probably done behavioral interviews before, and it'll be similar along those lines. And you just gotta go through that process. And also, when you're on one of these recruiter calls or when you're in a technical interview, they'll definitely ask non-technical questions in addition to your coding questions whenever you do an interview with a company. So usually, like, if you get on a call with some engineer, first they're gonna ask you some like behavioral things to get to know you better, and then they're gonna move into like a coding problem. So a lot of the questions you'll get are like, I think the most common one of all is tell me about a project you've worked on. That can be from like a previous internship, a personal project, and they just wanna see that you've built something that you're proud of, and what did you learn from that? And then, like, why do you want to work at the place that you're looking for? And this is a hard question to answer every time, but doing some research on the company beforehand and like seeing why it would be a good fit for you and showing that to the recruiter or engineer you're talking to is like kind of the best way to go about it. So now we'll get into the scarier part, which is technical interviews. And like, obviously, you know, I don't think any of you guys have done a technical interview yet, but it's something that, especially throughout college, you guys will become more familiar with. Also, were there any questions on any of the stuff I touched on so far, with behavioral interviews or like the process in general? No? Okay, cool. So technical interviews essentially are meant to assess your technical ability before you even like work there. So the reason these exist is because you need to be able to, the companies need to be able to validate that you actually know how to code, that